Hey everybody, this is a solution to the problem 2.13.16a in the Collaborative Statistics textbook. And this is a fun one. You got two box plots, got some data up here on the board. Actually you have summaries of data, not actually data itself. So we've got some false statements and it's asking explain why each is false. Your answers might very well be different than mine for this. I'm just going to give you some that I've got and you can decide if you like mine. If you don't like mine, come up with other ones. Number one, A.1, data 1, that would be the top box plot, has more data values above 2 than data 2 has above 2. Let's think about this. In data 1, the first quartile is 2. That means 75% of the data is above 2. In data set 2, the median is 2, which means 50% of the data is above 2. So right about that, you say to yourself, wait a minute, they just said to prove that this is false. There are more data values above 2 in data 1 than data 2. And then you realize, wait a minute, 75% of the data is above 2 in data set 1, only 50% in data set 2. We don't know how large these data sets actually are. If data set 1, say for example, has 20 data points in it, yeah, that's an easy enough number to use, and data set 2 has 100, well then, if this is 20, each of these quarters contains 5, which means there are 15 data points above 2. If this contains 100 data points in total, that means you've got 25, 25, 25, 25, which means that 50 are above 2 in the bottom one. So even though there's a higher percentage in data set 1, there's a higher raw number in data set 2. So without knowing the size of the data sets, we can't make that claim at all. If they were equally sized data sets, no problem. It's clear, but we don't know that. Okay. Number 2, the data sets cannot have the same mode. Okay, and this is where my math guy comes out. Some of you know I'm a trained mathematician, not a statistician, but as soon as somebody makes a claim like that, the data sets cannot have the same mode, it's a very strong statement. It means it can never exist. There's two things you can do with a statement like that. You can prove it or disprove it. Now they're telling us to disprove it, so our job is to figure out. So, why can't they have the same mode? Well, I'm going to say, let's just make up, we were talking about 2 before, I'm going to force both of these data sets to have the same mode. And I'm going to make that mode be a 2. I'm going to make that mode be a 2. Okay? So how could I make the mode be a 2? Well, if I put a 2 and a 2 in the middle there, I'm going to give each of these data sets 12 points, I think, just to kind of keep it interesting. This looks like it's 1-ish. I'm going to treat it as though it's 1. Okay, I'm going to call this 0. If I put a half in here, and then I put 3/4 here, and then I call this 1.25, right? And then I put another 2 in there. This guy right here is a little bit more than 2, so I'll call that another 2, and then I'll put a 2 point, that's a little bit more than 2, right? A little bit less than 3. I'm going to call that 2.4, and then call the data points here 2.6, and this largest one is a 7, we'll call this one a 6. There. There are 12 data points that fit this box plot, and they have a mode of 2. There are 4 2s and a bunch of other ones. Fair enough so far? Okay. I can do roughly the same thing with the top one. Roughly the same thing with the top one. I'm going to put the minute 0. I'm going to put 2 2s in this range, and a 2 right there. This guy is at 4, so I'm going to put 1 3 here and a 5 here. That forces the median to be at 4. Okay, you know what? Let's put another 2 there. Why not? Now we've got 3 there, 3 there. I got a 5. This appears to be a 5 as well, so maybe I should rethink that and call that a 4.1, 4.2, 4.9, 5.1, which puts the upper quartile at 5. That's a 5.1. This is a 7. Let's call this a 6. Boom. Got it. Both those data sets now have a mode of 2. Okay? Now, I'm not saying I can make up data sets that actually look like that. I'm not saying that at all. I'm just saying we disprove their statement because both of those data sets now have the same mode. Now, I also had them have the mode at the same frequency. That does not have to be the case. For example, you can change this to a 2.3, and now there are 3 2s here and 4 2s there, but you still have the same mode of 2. All right, and number 3, for data set 1, there are more data values below 4 than there are above 4. Well, let's go in here and just take out these superfluous data points I put in. All right. And you know what? While we're here, let's just erase data set 2, because we don't need it anymore. Okay, well, I erased access 2, didn't I? That's okay. That's what we need. Their claim: there are more data points below 4 than above 4. To which you reply, no, there can't be. What is 4? The median, the 50th percentile. That means half are above and half are below. Then you're going to say, rule, wait a minute, you just said we don't know how many data points there are in the data set. You said before, what if there are 20? What if there are 100? What if there are 12? Doesn't matter. Half of them are below 4 and half are above. So whatever there are, if there are n data points, if there are n total data points in the entire data set, there have to be n over 2 of them from here to here, and n over 2 of them from there to there. That's the definition of a median, friends. Hope that helped.